Hello, this video is primarily made for parents. Students are welcome to watch it, but the idea behind this video is to help parents understand how we're teaching addition and subtraction and why. Why are we teaching for understanding before we teach the old-fashioned way? We are going to teach the standard algorithm. That is the way that we all know how to add and subtract. We're just going to break it down into the very small parts so that students can also understand this way as well. So, parents, please feel free to pause the video as you need to pause it. Kind of think about what we're doing, or fast forward if you feel like you've got it. But this is just meant for you to help you understand what we're doing in the class and to keep you from rushing to that part of wanting just to teach the students, here, this is how you get the answer. And help us teach the understanding and really get that to hit home for the students. So here we go. Let's get started with our first problem. All right, our first problem is 23,456 plus 4,502. What we're going to do is we're going to use place value to do this. So basically we're going to use these dots, which are called number disk, and we're going to place them where they would go in the place value chart based on the digits there. So in our very first number, you'll notice that we have 2 10,000s, 3 thousands, 4 hundreds, 5 tens, and 6 ones. So simply I'm going to make sure that all of these are represented on the place value chart. Students have already used number disk, and we have already taught the place value chart. So this is just building on to that knowledge. So I kind of went in a pattern when I made up these numbers. I'm going to continue to do that. Now, students will not have disk like this to move on a piece of paper, so they'll be drawing their own. This is just easier for us to be able to see. So I need to keep going. I'm almost done with my ones. I have 6 ones, so I need to make sure I represent each of those 6 ones. Now, each disk is worth a different value in each spot. So therefore, each of these disks that are in this spot right here are all going to be worth 1. So this is 1, 2, 3, 4, 5, 6. These disks all have a value of 10. So this is 10, 20, 30, 40, 50. These all have a value of 100. So this would be 100, 200, 300, 400. These have a value of 1,000. So this is 1,000, 2,000, 3,000. And again, this is a value. Each of these disks are 10,000s. So together this makes 20,000. To this, we are going to add our next place value, which is 4 thousands. So in our thousands place, I need 4 disks. I use different colors just so it'd be easy for us to see. And when I made these discs, the red ended up being a little bit smaller, but that was not on purpose. It's just, that's just when I made them, they just ended up being a little smaller. So I need 5 thousands, and then 0 tens, and 2 ones. Now, what we're simply going to do is we are going to represent what we have going on right here with counting what we have in each place in the number disk. So, let's count. We had 6 to start with, the blue, plus 7, 8 altogether. So there's 8 ones being represented here. There were no reds, so we continue with just 5 tens, and they're worth a value of 50. Then, in our hundreds place, we had 5, and then we're going to add 4. So we had 4, and then we add 5, but it doesn't matter. Either way, it'll work, and that'll be a total of 9 place value disks. And then we add up our thousands. We can count them, and it is a total of, there you go, you got it, 7. And then we had no 10,000s. So when we were to add all of these place values together, the answer is 27,958. And we're simply representing this with the place value chart. So that is the answer there. All right, let's try another problem. Okay, on this problem, we already have the disk set up for us. We're going to be adding. What's different here is that we're going to have to be doing some regrouping and renaming. So that's what I'm going to show you here. And this is a very difficult skill for some students to learn. And I'm going to show you how we can show them this understanding before they do the standard algorithm, and hopefully this will help alleviate some of those struggles. So the very first thing we have is our ones, and we have 4 ones plus our 1 ones, which equals 5 ones. If you look here in our chart, on our standard algorithm, we would do the same thing. 4 plus 1 is 5. Now, here we have on our tens, we have 5 tens plus another 5 tens. Well, that would give us 10 tens, and we cannot have more than, you can, I mean 10 tens, you can have 10 tens, but we don't normally see that in a standard number. We only have one digit that can be represented. But when we're going to teach the children to group sets of 10, because each value is 10 times more than the one before it. So we're going to take these 10 tens, which really is just 100, and we're going to take that and we're going to regroup those as 100. So those 10 tens are now going to be represented as just 100, and I move that chart there. So if we look at our number disk, these are no longer counting because we've moved them to the hundreds, and so now we have 0 tens. Now how would that look like in the standard algorithm? Well, 5 plus 5 is 10, so we're going to bring down our 0. We carry our 1, and now we have that 100. It's no longer a 10, it's 0 ones and 1 10 or 100. So here we go. Now we're going to add again. So we have the one that we just had right here, plus we have 4 more, so that's 5. And then we're going to add 6, 7, 8, 9, 10 again. Now remember, we're going to group sets of 10, and the students are going to know every time you see a set of 10, we're going to group it and move it to the next value, because 10 hundreds make 1,000. So then that means I need to place that disk. So one of those hundreds is the same as 10 of those tens. We are no longer going to count those because we've moved it. And so we know we have 2 hundreds here. So how would that look in the standard algorithm? Okay, so we have 1 plus 4 plus 7, which is 12. The 2 goes here, and we carry our 1, just like we did on the place value chart. Now let's add. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 1,000s, and then 1, 2, 3, 4, 5, 6 10,000s. So the answer is 69,205. Let's go back to the standard algorithm. So we had 9 here, and 2 plus 4 is 6 there. So it's 69,205. Now, as you can see, the place value discs are going to be a concrete way that's going to help students understand what we're doing here when we're regrouping. We are renaming those 10 sets of 10 as the place value to the left, and that's just representing as 1. Let's try something else. Subtraction is a little different. Subtraction, you're not going to be adding any more number discs, you're going to be taking them away. So we already have 34,567 represented here in our place value chart. Those digits are already represented. We're going to take away 3,456. So when you take away 6, you're taking away 6 ones. So I'm going to come over to the ones, and I'm going to take away 6. So it's going to be 1, 2, 3, 4, 5, 6, which gives me 1 left over. Now I'm going to go to the 5 tens, and I'm going to take those away. 1, 2, 3, 4, 5, which again gives me 1 left over. I'm now going to take away 4 ones. 1, 4 hundredths, 2, 3, 4 hundredths, which again gives me 100 left over. And then I'm going to take away 3 thousandths. 1, 2, 3, which gives me 1 left over. I didn't do anything to my 10,000, so I'm going to record them like they are, and that's 3. So my answer is 31,111. Again, this is a very concrete way of showing students how to use that standard algorithm. This is a very simplistic problem. Let's try another. Okay, this subtraction problem is going to require borrowing, which means we're going to have to take from a higher value disk and create a group of 10 that wasn't there. So let me go ahead and walk you through it. Our first is going to be to look at our 1, so we have 6 there, and we're going to take away one of them, and that's going to leave us 5. That was simple. No regrouping was needed there. Then we had 3, and we're going to take away 2, which we can easily do because they're there. That's going to leave us 1. Now, here's where we have our issue. We have 4 disks, but we have to take away 5. But we really do have that value there because every single one of these disks represent 10 of the one before. So we're going to take this one and we're going to move it to this section here. But we're going to have to draw the 10 that represents. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is no longer there. So now you can take away that 5. You can take away 1, 2, 3, 4, and then that 1 more, which leaves us a total of 9 hundredths. Now, what did that look like on in the standard algorithm? In the standard algorithm, we would take the 6, we would cross it out, we'd make a 5. And then we would bring that 110 over, and that 4 becomes a 14. 14 minus 5 equals 9. My fingers are so big, I'm sorry. I'm doing the best I can to write. So now, what do we have? We have 5 1,000ths, and we have to take away 4, which we can do it because 5 is greater than 4. And that leaves us 1 left. And then there was nothing to take away with the 10,000, so it stays the same. So the answer is 11,915. So you can easily see how we can take this complex process of borrowing and making it into a concrete problem that students can easily understand. Remember now, we're going to be relating these two things with the students. We're just not going to start here. We're not starting at the standard algorithm. We're starting here at the place value chart to help make sure that we have that concrete visual for the students to understand. So when we move to this abstract process, they're going to understand it. The lining digits up is no longer going to be a problem because they're going to be thinking about, wait, that 4 represents 4,000s and not 4 10,000s. It just really helps students click, and it helps students get this addition and subtraction a lot faster. Let's do one. Okay, this subtraction problem is like the one we just did, except for now we're going to have to borrow over a 0, which means we're going to have to regroup more than one. So let's talk about how that would look for a student. Well, the first thing you're going to say is you're going to go to your ones and say, I have 1 to 1 and I need to take away 4. I don't have them. But clearly we have the value there because we have bigger values. So we just have to regroup. So we're going to have to go to the tens. Well, there are no tens. So that means we have to go further to the hundreds. Now we've gone 2 place values over. So we're going to take one of these hundreds. Excuse me. We're going to take one of these hundreds and we're going to have to bring it over to the tens. But 100 is how many tens? Right, it's 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that we have these 10, we can take one of these 10 and bring it over and make 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is no longer there because we traded it in, and this is no longer there because we've traded it in. So now, can we take away 4 ones? Yes, we have 1, 2, 3, 4, which leaves how many left? 1, 2, 3, 4, 5, 6, 7. Okay, now let's look at the next value. The next value is how many tens? How many do we have to take away? 5. 1, 2, 3, 4, 5. How many do we have left? 4. Now we have hundreds. We have to take away 2, which leaves us just 1 left. And then we have 6,000s, and when you take away 5, which again gives us 1 left. And then we have 1 10,000s that we're not dealing with. So the answer is 11,147. Now let's see how that looks in a standard algorithm really quickly. So we were taught growing up that when there was nothing in the next place to go to the next place, okay, that 4 is going to become a 3. That 0 becomes a 10, and then we can borrow from that 10, make it a 9, and then make this 1 an 11. So 11 minus 4 is 7. 9 minus 5 is 4. 3 minus 2 is 1. 6 minus 5 is 1, and then we just bring down the 1. So we get the same answer. You can see how this place value chart makes it very easy for those students to comprehend. And that difficult skill, and this skill is hugely difficult, becomes a very easy problem for them. Now, I hope this was helpful to you. I would like for you to complete the survey and let me know, if you understand what we're doing in the classroom better or not. It's okay if you don't agree with it. I totally understand. I've been teaching like this for 20 years. This is not a new Common Core thing. This is something we've been doing for a long time. It is just in the Common Core curriculum. And because you don't, remember learning this as a child because it was so long ago, it feels like it's new to us. But it's really not. We've been doing this for a long time. So please fill out the survey. Let me know what type of a job I did and helping you understand what we're teaching and why we're teaching it. Thanks a lot.